Welcome back. The diagram that we have in front of us is an energy level diagram that is showing different energy levels from n is equal to 1, n equals to 2, 3, 4, 5, 6, up to n is equal to infinity, where the energy is 0. There is a line from n is equal to 4 to n is equal to 1, indicating the transition of an electron from the fourth energy level to the first energy level, which is called the ground state. So the first energy level is called the ground state. Okay, the lowest possible energy level. From the second energy level upwards, electrons occupying these energy levels are said to be in the excited state. The energy level n is equal to infinity is the energy level beyond which an electron will escape the entire atom. So the energy that is required for that is called the ionization energy. We will deal with all of these in the coming videos. Going to the question, we are dealing with the transition of an electron from the fourth energy level to the first energy level. Now I will go on to read the question followed by the answers. The diagram above illustrates an electron transition from energy level n is equal to 4 to energy level n equals to 1. Calculate the energy of the photon, the frequency of the photon, the wavelength of the photon. We are given the Planck's constant as 6.6 times 10 to the negative 34 joules seconds and the speed of an electromagnetic wave as 3.0 times 10 to the power 8 meters per second. Solution. Question 1. To know the energy of the photon, that is the change in energy as the electron transits from the fourth energy level to the first energy level, and change in energy is equal to the energy at the initial energy level minus the energy at the final energy level. So that is to say, the change in energy is equal to energy at the fourth energy level minus the energy at the first energy level. But what if it was the opposite? That is, the electron is moving from lower energy level to a higher energy level. In that case, the change in energy will be the energy at the final energy level minus the energy at the initial energy level. Okay? Always remember that the change in energy has to give you an absolute value. It has to give you a positive value, despite the energy at each energy level is negative. So what is the energy at the fourth energy level? That is minus 0.85 electron volts. And the energy at the first energy level is minus 13.6 electron volts. So with this, we can be able to know the energy difference. The energy at the fourth energy level is minus 0.85 minus the energy at the first energy level is minus 13.6. So that is minus 0.85 minus is positive, so 13.6 minus 0.85 plus 13.6 is 12.75 electron volts. But we want to change this energy to joules instead of electron volts, and I will advise you to always change the energy that you have into the SI unit, which is joules. Remember that 1 electron volt is equal to 1.6 times 10 to the power negative 19 joules. So to convert the energy to joules, we are going to take the energy in electron volts and multiply it by 1.6 times 10 to the power negative 19 joules. Okay, so we can say the change in energy is equal to 12.75 times 1.6 times 10 to the power negative 19, and that is 2.04 times 10 to the power negative 18 joules. So that is the energy of the photon. The second question is asking us to find the frequency of the photon. Question 2. To find the frequency of the photon, we have to remember the formula. The change in energy is equal to the Planck's constant multiplied by the frequency. So if we have that formula and we want to find the frequency f, we are going to divide both sides by h, the Planck's constant. H will cancel h. That is, the frequency is equal to the change in energy divided by the Planck's constant. The change in energy is 2.04 times 10 to the power minus 18 divided by the Planck's constant is given in the question as 6.6 times 10 to the power negative 34 joules second. So 6.6 times 10 to the power negative 34. 2.04 times 10 to the power minus 18 divided by 6.6 times 10 to the power minus 34. That will give an answer of 3.09 times 10 to the power 15 hertz. Question 3 is asking us to find the wavelength of the photon. Question 3. To find the wavelength, we can use the formula: the speed of the electromagnetic wave is equal to the frequency multiplied by the wavelength. So with this formula, to find the wavelength lambda, we divide both sides by the frequency. So this will cancel this. That is, the wavelength is equal to the speed of the electromagnetic wave divided by the frequency. The speed of the electromagnetic wave is 3.0 times 10 to the power 8 meters per second divided by the frequency. We calculated it as 3.09 times 10 to the power 15. .0 times 10 to the power 8 divided by 3.09 times 10 to the power 15 gives an answer of 9.71 times 10 to the power minus 8 meters. So that is the wavelength. Alternatively, we can use the formula: the change in energy is equal to the Planck's constant multiplied by the speed of the electromagnetic wave divided by the wavelength. So with that, when we cross multiply, change in energy multiplied by wavelength is equal to hc. So to find the wavelength, we will divide both sides by change in energy. This will cancel this, so meaning that the wavelength is equal to the Planck's constant multiplied by the speed of the electromagnetic wave divided by the change in energy. The Planck's constant is 6.6 times 10 to the power negative 34 multiplied by the speed of the electromagnetic wave is 3.0 times 10 to the power 8 divided by the change in energy. We have that as 2.04 times 10 to the power minus 18. 6.6 times 10 to the power minus 34 multiplied by 3.0 times 10 to the power 8 is 1.98 times 10 to the power minus 25. Divide this by 2.04 times 10 to the power minus 18. So 1.98 times 10 to the power minus 25 divide by 2.04 times 10 to the power minus 18. We will still have 9.71 times 10 to the power minus 8 meters. So that is the wavelength. I would like to mention that we can be able to determine whether the light emitted by the photon is visible or not. Remember, when electrons move from one energy level to another, they are either within the ultraviolet light range or the infrared or the visible. If an electron shifts from any energy level to the first energy level, the light that is emitted is ultraviolet. From any energy level to the third energy level or the fourth energy level or the fifth energy level, generally the photon emitted is infrared. So meaning that it is when the electrons move from any energy level to the second energy level, that is when the photon emits light that is visible. Or you can remember it this way. When the wavelength is between 400 nanometers to 700 nanometers, then the photons that are emitted will be in the visible range. 9.71 times 10 to the power minus 8 meters, if we convert that wavelength to nanometers, that is by multiplying it by 10 to the power 9, we will have 97.1 nanometers. And because 97.1 nanometers is a wavelength that is not within the visible range, that is between 400 nanometers to 700 nanometers, we can state that the photon emits light that is not visible. Thank you very much for watching this video. Please subscribe to the channel, like and share our videos.